Welcome. This is my weekly summary of the work we've been doing on Twitch, and lately we've been working on a personal finance tool I'm calling Fiume. The goal is to treat money as either pools or streams and decide how to make trade-offs among them. Let's start with a demo. All right, so here we have our list of finances. We haven't added anything yet. We've got one empty graph. I don't know if we really need to show even that, but let's add some things. So let's give ourselves an expense stream. And I don't know, we're going to work on the interface for this stuff, but but let's say you start with expenses and you're going to spend let's make it minus $2,500 per month. All right, and we'll just start that right now. No end date, no start date. All right, so when we add this, we can see our graph is now 0. It's going down. Over 30 years, you're going to spend almost $1 million doing that if you don't have any income. So let's put in some scenarios. And these are alternatives, so we're treating them as scenarios. And I'm going to call this SS1 being Social Security for spouse 1. We don't use these names for anything really yet, but eventually we will. Okay, so this one's expenses. This is some alternatives, but you can tell it's empty. I guess I can click it that way. It's still empty. All right, so we're going to add some possible futures to this. So when we get to the code, this whole thing down here is called the possibilities. And it consists of a tree, which is a plan tree that represents all these in kind of one place. And then when we process it, we turn it from a tree of streams and alternatives and so on, groups, into a set of scenarios where the scenarios are just simple lists. They don't have any decisions. So each one kind of represents a possible future. Let's add, let's call it SS162. If you retire at 62, and I'm just making up numbers, I don't know, they all depend on your own personal situation, but for at least the US, 62 is like the earliest retirement age, barring other things. There's a million rules around it. All right, but let's say this starts, let's start in month 12, okay, and then go from there. So we'll see our graph now. We started spending, and then we got some income coming in. So in this case, it only takes us down to negative 200,000, which if you have 200,000 in the bank, you're kind of okay. All right, so let's add another alternative. This is SS167. Let's say if you wait 5 years, they'll bump it up to $3,000. And so 5 years past 62 is 60 months. So let's say month 72. All right. And now we get the multiple graphs. So the original one goes down and goes like that. This one goes down for a while. You've dug yourself into a hole, but eventually you get out. Almost out. You're ending up, 10,000 down instead of 200,000 down. All right, and a third alternative, and this one is 70. So this is kind of you can choose whenever you want to start Social Security, but if you pick a date later than this, they won't raise your money any, so not much incentive. So let's say $3,300 a month for that. And then it's starting 3 years later from 72, which is 108 if I do my math. Okay, and so we'll have this. Now, you can already see there's a problem that we're getting a lot of graphs, and that's a thing I need to figure out how to do this. You can also see these scenario names aren't very helpful. I just put a UUID on them so I could distinguish them, but right now they're just called scenario, and we don't really know the circumstances. I'd really like to get these names in here, at least like SS1, .1, .2, .3 for the 3 scenarios. Okay, but let's add another. Now this time we're going to add the second spouse. And we'll add another set of scenarios for that. I'll call SS2. Okay. And let's just put 2. I don't think it's adding a lot here. SS2, let's say they're choosing between 62 and maybe they'll get $1,200 at 62. They're a little younger, so we'll start them in month 24. And then add another one. And let's let them take the alternative of going to 67 and maybe, I don't know, 1,800 a month. And this is 5 years later, so 60 plus 24 is 84. Okay, and create. All right, so now what you see is we've got a pretty, well, it's an effective method of generating combinatorial explosion, basically. Every time we add a set of scenarios, they stack on top of the previous ones, in which case they multiply. So that's kind of the math of combinatorics. If I have 3 ways to do this and 2 ways to do that, then I have 6 ways to do any combination. But what you can see is these things have different turnover points. Okay, so the red one looks pretty good up until month 190 or so, and then just about everybody takes over, and then by month 250 the red is totally the worst. Okay, blue ends up the highest. I'm guessing that's the maximum one for both, but it takes you a while. It takes you almost 200 months to catch up. So it's definitely trade-offs. Each scenario calculates the data points for this graph, and that's the other major piece of this. So let me talk about the design a little bit. So the outer shell on the bottom there was the possibilities. So possibilities are created by adding either groups or streams or scenarios. In the future, we want to add people and add pools of money like 401k savings or whatever. But in any case, possibilities describes choices and lets you build alternatives. And so it knows the plan tree. The plan tree is the tree structure of the nested pieces. So the Social Security SS1 with 3 children, that's a tree structure. And then when it's got that tree structure, it can generate from that a set of scenario. A set of scenarios. I call the set scenarios, so there's a little ambiguity there. But a scenario is something with no choices left. There are no ands and ors or any of that stuff. It's just a bunch of decisions about which streams are active for this possibility. And that gives us the graphs. All right, now the core of that is this notion of an and/or tree. And what I think of it is it's a structure sometimes used like in AI sort of programs, at least old school AI, before LLM kind of stuff. You might have a search space and you want to walk through it. Maybe you're playing a chess game or something like that. And this structure kind of represents that. It's also a relative of regular expressions. If you take away iteration, take away the star or plus operator, you'd have ands and ors. Ands are like sequences, ors are like disjunction or alternatives. And so this, if you added that star operator, you'd have something that matched up to a regular expression. And so what we're doing with this is we're trying to say, here's an and or tree. Now I know it generates different possibilities. I want a list of those possibilities. And here's the algorithm I'm basically using to do that. So we'll look at this algorithm a little bit. We'll walk through the case, and then we'll see what it is in the code. All right, so the input to this thing is a list of scenarios. Normally we start with just one scenario and say, we haven't made any branching points yet. We just have a scenario. And when we started with that blank, line at flat line at 0, that was from that initial scenario. The output is also a set of scenarios. And if there are choices in the possibilities tree, it will generate multiple scenarios. If you didn't have any choices, you just said, here's this stream, that stream, another stream, there's only one scenario from that. Okay. And so the initial input is just that one scenario. All right. And so the tree has either got leaf nodes, which are our streams of income or expenses. It's got OR nodes. These generate a new scenario from each combination of the input scenario and the child. So if I'm coming into an OR node and I've got 3 scenarios and the OR node has 3 children, I'm going to take each of those 3 scenarios and try them with all 3 children. And so that's how I end up with 9 scenarios at that point. The takeaway on that is children build on their parent scenarios. So you've got an input scenario, each alternative builds on that. All right. And then the AND nodes, these are the ones that say you must have this and this and that. All right. So in our case, there was sort of an implicit AND node that said we had an expense stream and Social Security 1 and Social Security 2. And the difference there is the first child takes the parent scenarios, but each sibling builds on the result of the previous one. So children build on their siblings. And this is because the AND is saying everything has to happen. So the first child happens. We don't care what the parent started with. The new result is whatever the first child generated, and move on to the next, give that to the next sibling and go from there. We definitely got tangled up while we were implementing this. So if it's a little confusing, that's not to be totally unexpected. All right. We'll take that same tree and generate the alternatives. So what you want to think of is we're going to have A is going to have some sort of B, some sort of E, and some sort of F. The B is going to have either a C or a D. The E is fixed. There's no choice. And the F is going to have a G or an H. So given that, we have 2 things that generate alternatives and they're stacked on top of each other. So there's 2 choices for C or D and 2 choices in G or H. And so just not knowing anything else, we expect 4 things in our result set. So let's trace through and see how it goes. All right, so we start with line 1. The input is an empty set. And we're going to go to node A and say, hey, what's your result? All right, now A's result is going to be down on the bottom because we're tracing through a tree. All right, A starts with its first child. B, hey, what's your result given starting with empty scenarios, no scenarios? B says, well, let me ask C. All right, and C says, given the empty scenarios, I will put out a C, okay, because that's the only thing I can do by the time I get to that leftmost branch, leftmost leaf. All right, then we go back to the parent, B, and say, okay, now go to your next child and start with what you started with. Remember, all OR nodes take from their parent. All right. And so D, same thing. It says, okay, starting with nothing, I know I need a D in this. Okay. And so given that, we combine, we merge those 2 sets of scenarios, and C is one scenario set and C is one scenario, D is the other. All right. Then we're back up to A and we're saying, okay, now you take your E node and do that. Well, the E node is a sibling of B, and with an AND tree, it's gonna take whatever it got from its previous sibling. So that's a B, and the result of B was C and D. So that's why line 7 E starts with C and D, and then with a leaf node, you basically append yourself to each existing scenario. You don't generate new ones; you just append. So C and D becomes CE and DE. All right, and now we go to node F, and F gets CEDE as its input because it's getting it from the sibling. And when it passes it down, hey, G, given CEDE, what do you want to do? Well, I'm going to put G on the end of that, CEG, DEG, and similarly for H, CEH, DEH. Now we get them back from F. We're going to take the union of all of those, and the result for F is CEG, DEG, CEH, DEH, and because that's the result for the tree, that's also the result for A. Okay, so it's this notion of when are you adding to the parent's information or when are you adding to your sibling's information is kind of the critical piece that has to come together on this. And one of the pieces we messed up during the week. All right, we'll take a glance at some of the code. Okay, so I think the sort of interest that, well, they're all interesting how they work together, but the easier of the two is the or node. So we're given a set of scenarios, and we're going to produce a set of scenarios. That's line 101. If we have no children, then we return the scenarios we're given. We're not adding anything. Otherwise, we're going to build some new scenarios, and so our existing ones are all going to get modified or copied. You can see in line 109 that scenario copy, because the existing scenarios don't extend to these children, and those children must be added. So there's no reason to keep them. All right. So we basically run through each child. That's 107, and for each scenario. So if there are three scenarios coming in, each child has to handle three scenarios, and so we get that multiplication effect, the nested loops here. All right, and so what we do is we ask this child, hey, if you had the original parent copied, and I asked you for your scenarios, what would they be? And it comes back with the list of new scenarios. And so those get added to our result, our big scenario set. And, so it runs through those loops for each combination and then produces a result of scenarios, and we're good. All right. Now the I think trickier one, the code's actually a little simpler, so I don't know. But in this case, we've got the and tree, and we're looking at the scenario again. Scenarios in, scenarios out, and if there are no children, just return what you got. All right, and then we're going to do kind of an accumulator thing. I guess in a sense, I probably could have written this as a reduce loop, but in any case, we start with the scenarios that we're given, which is for an and tree, the first child gets the parent scenarios, and then each succeeding child uses the previous result. Okay, and that's where result is. For the first child, it started with the parents, then it runs through the loop for each child, and figures out what the child wants from the result scenarios, and that gives us a new result. And so we use that variable again for the next list. So that's the effect of getting the siblings information. At the end, you've accumulated across all those children, and you return that result. All right, and then finally, let's look at scenario itself. So these things are producing scenarios, which is the set of scenario. All right, and it's another object. The one I'm highlighting is this notion of adding a stream, because there's an interesting decision implicit in that's kind of independent of the and or tree, but it's a decision we're making. And what it is what if you have two scenarios? If you have two streams of the same name. So for us, we're saying future, later streams, if they have the same name, actually merge with earlier streams. So we barely have this idea in our code. Right now, it only works for the end dates. But if you have, let's say, salary and started off with no end date, meaning, you're taking it arbitrarily long, but then maybe we're doing retirement scenarios and we want to say, well, if I'm taking Social Security, maybe I better stop work that year, or maybe I want to stop work 5 years earlier, or whatever. But I can say, here's their new end date. And when it comes through into the scenario, it's got that original salary, you making $1,000 a month. Well, let's make it 50,000. Be generous. You're making 50,000 a month, and I hope you're saving a bunch of it. But if you come in at some point and say, hey, stop that at age 62. Okay, you retired from working at 62. And we're going to take that original one with arbitrary end date, and now we're going to apply just the end date. We'll leave the amount, and we'll leave the start date alone. And we don't quite do that right. We only handle the end date at this point, but that's where we're going. And so either it's a brand new stream we haven't mentioned before, we just store it, or it's an existing stream and we merge it and save that to work with for the next time that stream comes in. All right, and then the other side is what happens when we're generating those graphs. So I thought I'd run through that a little bit too. And the method we're calling is project. It looks like project, but in this case it's project, the active version. So we're projecting out through some range of months normally it's 1 to 360 in the way we are now, but it's, we may be flexible later. And so we're going to accumulate the monthly net worths. So we want a point for each month. What's your net worth in this scenario? And that's going to be the contents of the line. So we run through all the months in 32 and we build up this running total. What's your new net worth? And with each month, we attach data for the graph that the graph will use. And here you can see that UUID, this name scenario ID, will improve that too. But at least for now, that gives you something to distinguish the lines with. All right, and then it used net, which really just says take all the streams and add them up. Okay, so not too tricky. I mean, it's all kind of what you'd expect if you knew you need to get all those points. Graphs in Swift let you add in some extra information and so on, and we'll take more and more advantage of that. I think we're going to focus first on more user interface around the streams. I want to really bring out that concept of what are you overriding when you have a later values. Okay, so that'll come from that. We also wanted to color them, maybe distinguish income streams from outgoing streams with some colors, but eventually get to this overriding idea, make that more apparent. We don't have editing yet on the tree itself, and I'd like to do that. There's probably some simple editing that can be done for fairly cheap, and some more complex editing that's going to take some work. We'll do another version of this. I'm not trying to get totally deep on the facility there. And then also better UI around the graphs. I mentioned it's kind of hard to know like which these are great, but which combination is the winner? And I have to decode from these UUIDs, and I still don't know which one was which. We need to make that take advantage of names and numbers and make that more easily understood. All right. So anyway, if you'd like to join us, we meet every Monday through Thursday, 2 to 4:30 p.m. on Eastern Time, or 6 to 8:30 p.m. UTC. If you're there for the live sessions, you can go to xp123.com/Twitch. It'll bounce you over to Twitch. Or if you want to catch up from older ones, xp123.com/YouTube. They're delayed about 2 or 3 weeks at this point and lightly edited, but more or less the same. Okay, just a little behind. All right. Well, thanks for watching this summary, and I hope I can catch you online sometime. Bye-bye.